Hi everyone, welcome to today's STEM experiment. This week what we are doing is an experiment about density and buoyancy with a fun game called Will It Float? Density and buoyancy are two pretty big words, and I'm going to try and explain them to you the best I can so you can make good guesses as to what will sink and what will float. So bear with me a second and we'll get to the fun stuff. Okay, so first of all, density is how close together molecules are inside an item. Molecules are so tiny that you can't see them with your eye. You need a microscope to see the molecules. So, how are we supposed to know how dense something is? Well, we can't know exactly how dense something is without doing some math, but we can compare things to see if, say, a tomato is denser than a rubber ducky. Okay, the second term I want to explain is buoyancy. And buoyancy is basically how well something floats. Buoyancy is determined by two things. It is how much air something has inside it, and also the shape. So you have big boats floating on top of water, right? Now, how do they float? They're very heavy, right? They're made of metal, they're very big. But the inside of a ship has big empty spaces filled with air that help it float. Another thing, I said that the shape also is important for buoyancy, and that is because the more surface area there is on the water, the more buoyant it's going to be. So, say this marker is your boat. If I have it like this, there's all of this to float on the water, and that's how much surface it has. But if I turn it like this, it only has that much surface. So, which way is gonna float better? This way or this way? And that's how shape determines how well something will float or not. Okay, so enough about density and buoyancy. We are going to get to the fun stuff now. So it's time for Will It Float? Okay, so I want you to remember what I said about density and buoyancy. Something is more likely to sink if it's dense, which means its molecules are close together. It is more likely to float if it has air inside, and if a large surface area is touching the water. And sometimes you can't really know. We're just gonna have to guess. And that's all part of experimenting and doing science, is sometimes we have to do tests to find out our answer. So let's get started with Will It Float? The first thing I'm going to do is I'm going to float this yellow pepper, this tomato, and this lemon. So they're all fruit. None of them are made of metal or paper. It's all fruit. Do you think one of them is going to float better than the others? Can you think of one of them that maybe has a lot of air inside, or ones that don't have a lot of air inside? So make your guesses and we will get started. The first thing I'm going to do is our yellow pepper. So, will it float? Yes, the yellow pepper floats. So what does that mean? Does that mean it's buoyant? Does it mean it's dense? Well, let's see if that is denser or less dense than the tomato? Okay, so the tomato sunk and then came back up, where the pepper floated the entire time. So that means that the tomato is more dense than the pepper. And I'll show you why when we finish with this. So our tomato does float, but not very well. And now the lemon. All right, it did the same thing as the tomato. It went straight to the bottom, but then it came back up to float. Although I will say, I think the lemon went to the bottom of the pitcher faster than the tomato did. So I'm gonna guess that the lemon is denser than the tomato. So all three can float, but the pepper definitely is the best of the three at floating. And let me show you why. I'm going to rip open this pepper and I'm going to show you the inside. See the inside of that pepper? It's filled. Is it filled? No, it's got a big hole with lots of air inside. And remember, that's what I said about one of the reasons ships float is because they have empty spaces with air, and the pepper has the same thing. Okay, so that's enough of food. Let's move on to metal. So I have two different types of metal here. I have a ball of aluminum foil, which is pretty big, and I have a screw, which is a lot smaller than the aluminum foil. But testing them out, for how small this is compared to the aluminum foil, it's a lot heavier. And something's density isn't determined by how big it is. It's how close those molecules are together. So, if this tiny thing is very close in weight to this big thing, what do you think that means? Which one do you think is denser? Let's find out. So first we are going to do our big ball of aluminum foil. And it is worth saying that these are two different metals. This one's aluminum and this one is steel. So does that make a difference? Let's find out. In goes our aluminum foil, and it's floating. It's metal, and it's big, but it floats. So, we'll discuss why soon. But first, our small piece of metal, what do you think it's going to do? Well, that just sunk right to the bottom. Immediately, it's not even coming back up at all. So, what does that mean? Sorry. So, that means that this tiny little thing is more dense than the ball of aluminum foil. But also, the ball of aluminum foil I crumpled up earlier, so it probably has little pockets of air inside of it, which helps it float. So two metal things, two different sizes, but two different results. Okay. I'm going to try a couple more items, and I want you to guess, will it float? We have a rock. I know it looks like a panda, but I painted it to look like a panda. It's actually a rock. And we have a rubber ducky. What do you think? Is one of these made to float? What do you think about the rock? What do you think is going to happen? And that went right to the bottom, and the rubber ducky is floating along on top. So what does that mean? That means that the rock is denser than the rubber duck, and the rubber duck probably has some air in it, where the rock has none or less. Okay, so I have one more thing to compare. I have a marker, the one I showed you earlier, and a crayon. The marker is bigger than the crayon, but you remember that the aluminum foil ball was bigger than the screw, and still it floated. The aluminum ball floated even though it was bigger. So size doesn't always mean something is heavier or more dense. Can you think about the way the inside of a marker looks? How about when you break open a crayon? What does that look like? What do you think is going to happen? Well, why don't we put them both in at the same time and we'll see. So, the crayon sinks and the marker floats. So, remember that means that the crayon is more dense than the marker, and also the marker inside has an empty space with air in it, which remember makes it more buoyant, which means it will float. Okay, so I hope you had fun with this experiment. This is something you can easily do at home. All you need is a container of water and some various items. So, if you had fun with this, I want you to try this at home with more objects. Just make sure you ask an adult before you put anything in water. Okay? Promise me? All right, I will see you next time for our next STEM experiment. Bye.